Okay, everyone, welcome to a special edition of C++ London Uni. We have a very special guest for you today, as some of you who attended last week will, of course, know. We have Peter Bindels, who is going to be introducing you to the wonderful world of 2D graphics in C++. So hopefully at the end of this, you'll have learnt a lot and built something rather cool, maybe. So as usual, thank you to Mimecast, my employer in this particular case, for hosting us. It's a bit of organisation to get done, but we are here. So once again, thanks to them. And of course, thank you as well to all of our Patreon sponsors. We do very much appreciate your support. It enables us to buy, cool stuff like this, and maybe hopefully one day it will get us to a level where we can just get space as well. Yes, and on that note, if anyone can help us find space, please do let us know. Maybe your employer has a room that they can let us use, anything along those lines. If you know of some public facility, preferably if you can get in touch with them and let us know the outcome, that's better. But if not, then let us know of who it is, and we can obviously engage with them ourselves. As usual, the lesson structure, this is sort of fairly familiar. A permanent feature of our intro. The Tuesdays, today, our main event, the lectures and the exercises, obviously slightly different this week because of our very, very special guest. And of course, we have the Thursday workshops. So hopefully you'll all be tremendously inspired today, and you'll all want to go and hack away at making some little games on Thursdays. And of course, supporting us, we have our Patreon. If you like what we do and you want to sort of help us with this project, then consider becoming a patron. If you know that your company has any kind of outreach departments and they might be interested in sponsoring us, then please get in touch with us as well. And then, of course, you can just socialise. Come and join us at the pub, have a drink with us. Buy this great man who's about to present a beer at the end. And then there's, of course, our USB sticks. So for those of you who don't want to have to faff around just setting up everything on your laptop, you can just get a USB stick off us. Suggested price is £15. If you're feeling generous, then we won't say no to more, of course. And it's got a complete live environment. It just boots, and everything is saved to the USB stick. So if you take it out and put it in a different computer, it just carries on from wherever you were. And of course, there's always Twitter and LinkedIn. It costs you nothing. Please retweet us, spread the good word. And of course, always do check our c++londonuni.com website. And on that note, I'm going to hand over to Peter, who's going to come up here and begin the lesson. So for those of you who are watching on YouTube, you are briefly going to have a cutout in audio while we do the transition. So bear with us, please.
Okay, so if I understand everything correctly, we should be live and everybody should be hearing me. Is there a way to check if everybody online can hear us as well? Okay. Okay, let's see, how do we click with this? That's how we do that. Okay, so welcome. I'm going to be telling you a few things about 2D graphics. So the first question is, why did I even start programming? For me, it's a long time ago. For you, it's probably a bit less. I actually started programming because my dad bought a computer, and it was this one. This is a really ancient kind of computer. This is one that has 64 kilobytes of RAM, which is like 0.000064 gigabytes. It ran at 0.0009 gigahertz, and it could display something on screen, and you could play games. And of course, me being 5 years old, games are awesome. Until at some point, the game said syntax error in line 374. And I'm like, what do you mean? I'm just playing a game. Why are you crashing on me? But wait a second, line 374. I know this list command. What does it do again? So list 374, enter. There's a line of code. What happens if I type list, which you also use for directory listings, and I just see the entire source code of the entire game? This is how you make games I have to learn how to do this. So of course, I went on from that point, tried to make games, mostly just taking a game, modifying one tiny bit and seeing if it works, and if it didn't work, then you turn off the computer and you try again tomorrow. Until at some point, this thing got to be essentially old trash, and we got to a new computer, an IBM PC. And we had this game. Does anybody know this game? That's three hands, I think. So this is Nibbles, which is a snake game. And Nibbles was special in that it came with your computer. You got QBasic, which was a free development environment. You got a basic compiler, interpreter technically, and you could just modify the game. It was meant for it, and that was awesome. So I played the game. It's a fun game. It's sort of interesting, and I figured I should try to make this more interesting. So what happens if I just take the borders and remove them? Of course it crashes, because that's what it should do. So what if I just make it go off the end on the left and then come back on the right? And vice versa. That worked. Then you change color, you do some other things, you make it go really, really long, impractically long, and then you get bored and do something else. But I slowly transitioned to a PC. And I programmed in BASIC until essentially BASIC gave up on me. It had a limit of 100 kilobytes in the source file, and I managed to get there, so it would refuse to load my source tree. There was a thing about building things in separate files, but, you know, don't have time for that. I don't understand that. So I got to new games, and then I found this game. So this is basically around 95, 96 time frame, and this is a really nice game. So I'm playing this game just every evening, and at some point on a Saturday afternoon, all the shops had just closed, and it would crash, telling me there's an assertion failure in this CPP file on that line. So I was annoyed. So I tried again, start the game again, get to the same point at the same level, crash again. Try it again, start it up. Save every minute, because this is annoying. And I get to the point just before that, and then it crashes. Start it up again, crashes in 3 minutes. Start it up again, crashes in 2 minutes. This is getting on my nerves. So I just go do something else for an hour, having a suspicion what it might be, come back, try it again, and it works for 5 minutes. And then it crashes. So when this game came out, computers weren't actually cool yet. And this was the first one that I had that actually required having any kind of active cooling. So I opened the case and tried to see what might be wrong, and I found this one. So this is the exact kind of cooler I had, and these pins are supposed to keep it attached to your CPU. And those pins were not very good at that. Nowadays we have giant mechanisms attached to your motherboard through the case to keep everything attached. This is just a plastic pin to sort of pull it on. And it, yeah, sort of didn't. So I figured, well, what do you do when you're 13 years old? All the shops are just closed. It's Saturday evening. I have a whole Sunday to get through. What am I going to do? So, of course, you get a glue stick. You just glue it back on. Thank you, Mac, for ruining the graphics. So, that's the way I got into C++, because this game is written in C++. I have to go do that. So when 13 years old, I just go buy a book, try to read it, and figure out how to write C++ code. It's kind of difficult because at that point there were no free compilers available. So the best thing you could do is try to get an illegal copy, which is, you know, not quite legal. So you did that anyway, get a Visual C++ 5 compiler from somewhere, which is ancient now. Long story short, we get to here. So I'm here to talk about 2D graphics. But how many people actually play any kind of 2D graphics games anymore? That's a remarkable amount of people. Because actually, 2D graphics are all around us. They're in all sorts of games. So I'm playing this game. This is on Android. It's a mobile game, but it is a 2D game. And if I'm looking at how complicated this game is to make, I have a single image for the screen, I have images for the cards, I have images for sparkles. And that's all it is. It's just some 2D images copy-pasted together. That's not very hard. You can make poker. Add some chips. It doesn't look as 3D and as nice as this, but you can make a poker game. You can play against friends. Not for real money, of course, because rules. But even big companies nowadays do 2D graphics. One of the biggest hits of the moment that was started, I think, last month is this, which is a game from the 80s, from Russia, that was basically reinvented by Nintendo to play head-to-head with 99 other people. So you play this on a Nintendo Switch. It has great effects when you see it in motion. But if you look at it up close, these are just rectangles. They are just white-colored. There's nothing intelligent about it. There's nothing really complicated. It's just a whole bunch of things. And a nice background. And there's more 2D games. There's this one. Does anybody happen to know this one? Which one?
My brother's played.
To your brother's play. Do you know the name?
Terraria?
Yes. This is Terraria, which is a game with a whole incredible amount of content. And it is 2D graphics. It's just tiny blocks pasted together with a whole lot of blocks and a whole lot of complication behind it. But the graphics are easy. There's this one. Probably somebody may know. Yes, so Ollie, this is?
It's Factorio.
It is Factorio, which is basically well known for having a whole lot of complicated stuff going on in the background, but everything you see, despite looking 3D, coming from 3D models, is 2D graphics. So 2D graphics is not old. It's not something that's not used anymore. It's something you can use right now to make a game like this. Go on Indiegogo, get some money, fund your own game company, go do things. It's not a joke because the people who made Factorio did do an Indiegogo and they got their funding there. Oh my, I am hoping that you have a font installed because this is a little bit little. It's going to be hard to present with that text. I think you don't have the font installed. I don't see my text at all.
Oh, crikey, that's a bit of a technical complication.
Yes.
Do you have the font?
It's one of the system standard fonts. You should be able to replace it with anything else, but this is going to be
I
difficult.
See what you're saying. Yeah, we can. Okay, bear with us, folks.
Yes.
Technical difficulty.
Apologies for this. We should have checked this as well.
That's a picture.
Can you go to another slide?
Yes, picture. Change picture.
So why the picture's not there?
What did you use to present this normally? What app do you normally use? So I could try.
LibreOffice.
Should work in PowerPoint then, but I can try Keynote. Right.
So apologies for the slowdown. We have some technical difficulties.
Some technical difficulties indeed. No, it doesn't know. ODP is PowerPoint. So,
Can you just scroll a bit down to see if the text is there? Because if that's true, yeah, that's all blank.
that's not.
Those are images.
Okay, let's have a look what's going on. This is not good, is it? Showing up as a picture.
I'm pretty sure I know what the pictures are, but they are kind of required for the line.
Yeah, we can't start.
If not, we'll just do without.
We could might as well switch to your laptop at that point. There's no point streaming it if it's all blank. Do you want to switch to your laptop?
Sure.
Yeah, okay, go. Right, I'm very sorry, folks.
Can you be sure to publish the slides to the Slack channel so everybody who's joining online has them?
Yeah. So, we're going to disconnect the station. Check which phone. You say LibreOffice?
Yes.
Right, let's just do the simple thing. Right, we're not going to give up. We're going to try and download LibreOffice. And see if it helps us. 238 megs. Okay. 40 seconds. Sorry for the delays. Getting there. Yeah, I didn't even notice that. It's unfortunate.
Yeah, didn't expect this to happen.
Okay, so if you use LibreOffice, it's possible.
So while you're doing this, let's just slowly continue. So one of the questions I had was thinking that we have a whole lot of 2D graphics. 2D graphics is not that complicated, it's not that hard. C++, I learned it myself a long time ago. I remember it being really hard. So why is it actually so hard to learn C++? Is something inherent in the language? Is something imposingly complicated about it? Is there some reason why we can't just understand C++? So I put the question on Twitter, which was the first image that was missing, basically asking people what would be required to make C++ a good first language. And the first reply is the one that you expect. Nothing's going to make C++ a good language. If you want to learn low-level stuff, learn C. If you want to learn high-level stuff, learn Java. Well, yeah, that's an answer, but it's not helping me any. And actually, it's not even true. Because there's a project called JewelBots. Has anybody heard of JewelBots? That's a hardware project where you have a gem. It's a jewel you can make into a wristband or a necklace, and you can program it in C++. It's aimed at young girls. And there are kids, 9-year-old kids, presenting live on stage at CPPCon, which is like 1,200 people in the audience, how to program in C++. So that's hugely impressive. I was not on stage at 9 years old, and I'm dumbfounded she can do that. But maybe it's just girls. Maybe girls are just really, really good at software engineering, and we just haven't figured it out yet. But there's also Arduinos, and robots built with Arduinos, which are also programmable in C++. You can use Python, but you can use C++ as well. And small kids, small boys are programming those as well. Small girls are as well. So maybe the problem is just not the language. Or maybe the problem is in part of the language, but just something else about it. So I got a reply from Patrice Roy, who is a professor at a university in Canada. And he basically says, well, I teach C++ every day. I know what the problems are, and the problem is not C++ the language. The problem is the stuff that are getting taught from C++, which is pointers and C and all that kind of stuff. There's a bunch more replies from people who basically indicate that the problem with C, or with C++, is that you actually start by teaching C, and then you start by teaching all the things that you now have to forget again. Because you learn pointers, and then you get taught you shouldn't be using pointers anymore. And then you get smart pointers, and you shouldn't be using the smart pointer everywhere, and it just builds up a complexity, even without getting you anywhere. So the big answer to the first question is, maybe we should just stop teaching C. And now I could give a good talk about not teaching C, but it's a talk that's already been given by Kate Gregory at CPPCon in 2015. So instead of talking about that, let's go to the second part. You have more images?
I believe we've got a fix. So which?
I don't know if I can call that a fix.
That's This is LibreOffice. That's
Yes.
for sure. What the heck has happened to it though?
It's zoomed in way too far.
Do you reckon we can change it?
These are most meant to be pictures of a tweet.
Oh, I see.
I don't think this is fixable in any kind of reasonable time frame.
How bad is it?
Half the slides, I guess.
Probably enough to go by, isn't it? So what's happened? Is there a zoom on this? Do you know how to edit this for zoom?
Nope.
Position and size?
I zoomed in a little bit, but not a lot.
Yeah, I think it's scaling to the top, isn't it?
Yeah.
Original size?
Nope, it's cropped.
Okay, I guess we'll look at it. What slide did you get to?
Can we swap to the other one?
Is it 11?
No, we got like 7 slides further down. But can we switch to the other one?
Yeah, you can switch to yours, yeah.
Because at this point I'm going to need some slides. Especially because talking without slides is a bit dry.
The slides will be shared later. We will soldier on with audio only.
The slides will be shared as soon as Ollie gets to it.
Yeah.
And we'll switch to a different laptop now to present with slides and with actual contents. Yep.
We can use your clicker if you want.
Yeah, let me use mine. Okay. I only get one display. I only have one display.
Let me try and fix that.
Let's try plugging it again. We've tried this before we went live.
Yeah, it's HDMI 1 on this projector set.
So this is a 9-year-old girl on stage giving a talk on how to do C++. This is just inspiring. So these are the Arduinos, and they can drive around, they have colors, they have lights. It's a lot of fun. So language isn't the problem. The problem is that we've been teaching it wrong. So just remove the entire heritage from C. Just stop telling people about all the C stuff. And just use the SCL, use algorithms. So good job there. We should be using the SCL. And no pointers. So just watch Stop Teaching C from Kate Gregory. There's a link, but you can find it easily. She has a great talk on it. We're not going to dwell on it any longer. So the second thing we need are libraries and tools. Because we can do C++ and write everything from scratch every time again, but if you do that, you're going to be spending a whole long of time getting anything running. You can make something on the library provided by your platform, but if you do that, you're tied to that platform and that version of the platform. So by the time that you have something developed, Microsoft will have gone to the next version, or Linux will have gone to a new standard library for audio, and you'll have to start again. So we need libraries to do things. We need better tools. We have build systems, but they're not good. They require a whole lot of manual configuration. They have no standard way of finding libraries. There's no package manager that you can just say, hey, I would like to get a 2D graphics library. Do you have like 3 recommendations? We don't even have one. You can say, well, I'd like to have this graphics library. Can you please get me the one that works? This just doesn't exist. It's kind of silly. We need package management. So we need to have this stuff so that it works. So we need build tools, we need package management. We'd like to have a nice IDE so we can show how to do things. We can have a standardized way of working with things. There's one more thing that we need. And this is one that I saw in a whole lot of messages, which is beginners, if they're not academic, need to be impressed with quick and visible results. And this is a point I'm thinking about myself. I needed to be impressed with quick and visible results. Interfaces are good. The one thing I request is having some sort of environment, so you can actually do stuff straight away, which is open the window and draw stuff, because just dumping stuff in C out is not interesting. Well, it offers a simple way to show something visually to the user. Shapes, text, etc. Console output isn't exciting. And then the moment I was assembling the presentation, I got this message, which is somebody saying, I remember my Casio programming something in math class so that I can have a 3D projected cube rotating on screen instead of, math. And that's the best thing to get started, because the results are tangible and immediate. There's stuff you can see, there's stuff you can do, and if you mess it up, if you have some bit of trigonometry done wrong, you will see that it just doesn't work, which means your math is not just math, it is math that is visible. You can see it, you can almost touch it. So we need to have quick results for beginners. There's one more thing we need for beginners. And to explain that, I'm going to need to explain one joke. Does anybody know this joke? It's close to that. So there's a farmer, and he's trying to get some more milk out of his cows. So he's trying to go for any kind of method, and nothing seems to work. So he basically goes to the nearest university and says, well, I need you to come up with some kind of way to make these cows give more milk. So they go into a meeting, come back a week later, and they present their results. And they say, well, this works, assuming that we have spherical cows in a vacuum. So the trick there is that you take a problem that's really complicated, and it's hard to attack, it's hard to do something with, and the first thing you do is simplify it. So we simplify it to a spherical cow because we can reason about that. We do things in a vacuum, so there's no air bouncing around. So that's the thing we should be going for. We should go for simplicity. So simple 2D graphics. So what's simple? Yeah, I went to the dictionary. I'm not a native speaker, and I just figured, well, maybe they have a really good, simple definition for simple. It's hoping for too much. So simple, lacking in knowledge or expertise. A simple amateur of the arts, or free of secondary complications. A simple vitamin D deficiency. Note, by the way, that I've left a few out, because there's too many. There's 5C1, which is having only one main clause and no subordinate clauses. A simple sentence. Or of a subject or predicate having no modifiers, no complements, no objects. Maybe it's constituting a basic element. It's fundamental. It's not made up of many like units. A simple I. It's free from elaboration, free from figuration, not subdivided into branches or leaflets. It is readily understood and performed. And these are just the ones that apply to what we're trying to say. So maybe simple is the wrong word to look up. Maybe it's not simple. Maybe it's intuitive. We're doing graphics. It should be an intuitive interface. So what's intuitive? Well, intuitive is something that's known or perceived by intuition. That doesn't help. It's knowable by intuition. It is based on or agreeing with intuition. So this would be an answer if we knew what intuition meant. But it's also readily learned or understood. That's useful. But then, what's intuition? So if you go for this, it's basically experts using their base of expertise. So we can make something simple if it works for experts. That's not making any sense. Okay, this is not making it simple. So what do we do to make it simple? We start with the assumption that you know nothing. So you start with having just basic procedural flow. When we're making a program, we want to make a simple graphics demo, and we're going to start with absolutely nothing. And the first thing we learn is that the program goes from top to bottom. There's no way of stopping. It just keeps going. Second thing we add is having things, having lifetime, having objects. Third thing we do is having a function call. Maybe we can make it wait for like a fraction of a second or a whole second so we can see what it's doing. Then we add a while loop so you can keep doing things. We complicate it with an if statement. At that point we start adding creating functions. And by this point, you're able to do C++, at least at a basic level. You're all past this level already, which is good. So the first thing you do is start with basic procedural flow. We have an empty program. It does nothing. Successfully. And this is actually a shipping program, because there is a program on every Unix and Linux computer, so Macs, Linux, all of those, that does nothing successfully, and it has a man page. It's called true. It's a program that literally does nothing successfully. There's also a second program which does nothing unsuccessfully. It's called false. So then we add some things. We create a window. There's a window, we can put it on the stack, and when we get to the end of the function, the window disappears. You start up the program, the window appears, it disappears. The lifetime starts after the line completes, so the window comes up as soon as the line is complete, and the lifetime ends when the end of the scope is reached. So by the time we get to the last brace, the window is destructed. We see a window, but it's only flashing. The next thing we do is add a function call. We add a sleep. And now the window appears, it sits around. And the operating system at some point says, this is not responding anymore, would you like to kill it? Well, okay. We are technically sleeping, so we're not responding. So maybe we can do something else than just sleeping? And at this point, we can actually just do a demo already. Let's see if we have the demo set up and ready. It's on the wrong screen. Ah, that works. Let's set the terminal to a presentation profile. That's better. Can you all read this? Okay. That's in That's me getting lucky. The demo is actually on this screen. Let me switch the entire presentation to a single screen so you see the result of the demo and not just the invocation. Yes, keep changes. Go to the demo again. That's a window. It has a pixel. It has a color. We can modify it. So, name a color. Red. So we can change this to be red. We build it again. Now it's red. It's a really tiny program. It's no bigger than as much as we can understand. And it doesn't have for loops. It doesn't have complicated things. It just has objects, lifetimes, function calls. And you can already start with this without understanding the rest of it, changing things. You can change the number that we are at. You can change this location to be 0. Recompile. Try it again. It's down in the left column. There's a whole lot of stuff you can already do without actually knowing all the complicated bits of the language. So then we go one further. So while we should not close, let's show the window. And then we might be able to display some text like hello world, but in graphics. But we can do more interesting things. We can load an image and just swap some pixels. So what we're doing is just taking the image itself and then picking 2 random pixels and swapping their color. So over time, all the pixels on the left and the right will move slightly around, and the image will be distorted. So we have a graphics demo. This is like 2 minutes of work. We can make graphics demos. That's fun. So let's go one step further. We can have an if statement. So we can say if we have an argument, then we say hello person. And if not, it will just say hello world. But we only have a C-compatible main function, so we would need to show you pointers, and we don't want to explain pointers at this point. So let's not make that example. But we can create a function. And at this point, you just take this, you expand the main function, you add a whole bunch of new things, you add 15 different pixels to be plotted in different colors. If you do that, add some sleeps in between, put them into separate functions, you have a demo. You have something that starts up, it shows screens, it varies from screen to screen, it animates something. You can show things moving around, you can have really complicated things. Does anybody happen to know Conway's Game of Life? There's 3 hands. I first got a demo from somebody showing me Conway's Game of Life and not telling me, being a kid that was, I think, 14, that Conway's Game of Life is nothing like a game. So it's expecting something with keyboard input and something you can play around with and something happens. But it's actually a mathematical thing. And what it does is it takes a number of pixels, and given the state of the pixel and the pixels around it, it applies a convolution to it and determines a new state of the pixels. Which means you get a different state. And given that new different state, you can apply the same thing again and get a new different state. Doing that often enough gets you an animation. And given clever enough rules, you can make it so that everything keeps changing and it doesn't go into simple patterns, but it goes into complicated things. So this looks really complicated. And the actual mathematical bit behind it, the stuff that Conway did for us, is actually kind of complicated. But writing this as a demo takes 40 lines of code. I'm pretty sure you've all written programs that have 40 or 50 lines of code so far. So this is not something that's out of reach. You can make this. And of the 40 lines, 10 lines are taken up by just the bit that shows the initial state, which is, I think, 11 pixel puts, which is this pixel has to be white, and that one has to be white, that one has to be white, which is the minimal state for an interesting example, taken from Wikipedia. So that carries on for a bit more. I think it does end with this wraparound setting. We can go beyond Conway's Game of Life, because we're still doing a simple demo. What did we not use so far?
Input.
We did not use input. Which things in the language did we not use so far?
Templates, exceptions,
Templates, exceptions.
classes. So
We did not use any classes. We did not use inheritance. We used no virtual.
functions.
We did use functions.
Functions, but we didn't write except for the main function.
At this point in the Conway demo, we did actually write a single function, but that's mostly to clean up the program. So you didn't need to do that, actually. That's a good point. So we have an init function. It has a Conway function, which looks complicated on this zoom level, but it's not actually that complicated. It's basically the Wikipedia rules and the main window. Yes, there are functions, but you could have done without. Would just have been a big main function. But we also didn't use any C. We didn't use pointers. We don't need pointers, so we're not using them. We don't create a class. We have no inheritance. We have no virtual. We didn't use a header. Because at this point, our demo is still 40 lines of code. It fits on your screen. There's no reason to put it in a separate file yet. There's no reason to make complicated build systems. Which means my compile can be just a single command. You can use clever build systems. You can use tools that do it for you. But you don't need to use it. So we just didn't use a build system. We don't need to have configurations. We don't need a release and a debug build. Because this is still, for my computer, a simple demo. For us, it might be an enormous amount of time to calculate how exactly to put the pixels, how to move things around, but my computer runs at a mind-boggling speed, especially compared to the first one I had. So this one is just sitting there with two fingers up its nose, doing nothing. We didn't use libraries. I'm cheating because we used one library, set up to make it easy to use, but beyond that point, we used no libraries, we made no libraries. We tried to keep things as simple as possible. We haven't used any warning options, which is a bit of a shame. We should have done that. It would be nicer to compile with warnings. But I'm going to leave that to Oli for a different lesson. We didn't get into any licensing trouble. We just have a simple library, and we can use it for anything we want. The library I'm demoing is one that is specifically made so that there will be no licensing issues. You are free to take the code, do anything you want with it. Release it under your own name, feel free. So the best thing that we can do is get started with something that works. So we start with a simple demo. Doesn't matter how simple or how complicated it might seem, as long as it's mostly simple. So we take something that works. We take one of the examples, and we modify it somehow, just like we did. We changed the color, we moved it. Then we compile it. Then you run it. And you get that enormous feeling of it actually works. I made this change and it did something on my computer. I made a game different. I made a demo different. And I am the one who now understands how this works. And that feeling of reinforcement, that is such a good thing. So we have a few more demos, because demos are fun. Let's see. So this is one that I saw as a screensaver on my computer 25 years ago. And initially, when you look at it, you're like, this looks kind of complicated. I don't even know what exactly this is all doing. This color's moving. So the thing is that it takes a set of colors and it just puts random colors everywhere. And then in every of the possible positions, it looks at the color and sees if the next color in the cycle is next to it. And if so, it replaces it. And it does that for every pixel on the screen, every frame. It's just in software, on your CPU. And that leads to a nice pattern, because on this pace, most of these pixels have been surrounded by different colors, and as they progress along the screen, you know that the next color is next to it, which propagates back. In the end, this thing will take over the entire screen. So this looks really impressive. This is simpler than Conway's demo. We can use a little bit of trigonometry and make a star field. Because what is a star field at this point? It's just a bunch of white dots. It's a screen, it's filled with white dots, and the one clever thing that we're doing is moving them away from the center. That's all we do. And then we request your brains to make this into a star field by just saying this is a star field. And then you think this looks like a star field. We're just moving pixels. And then we have a bit of human input, because of course we would like to have some kind of game input. So we have a mouse, we can give it a mouse trail. This one actually sort of relies on the computer being slightly faster than it is in the demo mode, which means that the mouse trail will dissipate at the end as soon as it gets far enough. I tuned it for the speed that it normally runs on my own screen, and this is a bit slower. So we have some human input, and we can use it to make a game or make a program. So how about we add just a little bit more complication? This is not a lot more complicated. This is just images being put on a screen. It's like a pixel, just put an image somewhere. We still have the same kind of keyboard input. So I can move. If it feels like, if I use the right keys, it works. So I can move around. We have some screen scrolling. We can even jump. So somebody wanted to make Super Mario? Go right ahead. We have a start. We have a few bugs, like we can just launch into outer space. And we can crash down with no issues whatsoever. So maybe there's things you want to tweak. Maybe you want to replace the graphics, because I'm trying to use free graphics. These are not copyrighted, so you can use these and release a game. But you could use copyrighted graphics in your own game. So then the next question is, where do you actually start? Because I've shown you a bunch of demos. Those were written with Pixel. There are different libraries you can use for 2D graphics. And, for example, you can use SFML, which is a different library. It is much more full-featured. Pixel is basically a simple library. SFML is meant to be a full 2D graphics library and having all the options you could want in 2D. There's also Allegro, which is a very old library. I think by now it's almost a quarter of a century old, which you can also use for 2D graphics. So I would try not to use Allegro. I'm just naming it because it's one of the most well-known ones. There's SFML, which allows you to do a whole lot of 2D graphics, but the knowledge you gain with that will be in 2D graphics and will stay in 2D. You can also use Pixel, which is set up to be essentially as simple as possible, and it is based on a 3D environment, which means that all the stuff you learn there will translate easily to 3D if you want to go there. You can keep using it in 2D. You can use all the 3D things that might be nice to be used, like shaders and animations and sort of different effects, but you don't have to. You can keep everything in 2D. You can just keep using the library. But it's meant to be poked through, read into, understood by anybody making the software. It is meant to be a simple library itself, and it will teach you basically how to use SDL with OpenGL. And both of those are used in industry for making games. So this gets you started. You could also say, well, I know 2D graphics. 2D graphics is fun, it's nice, but I actually like 3D more. I'm just going to make the next Doom, or Rise of the Tomb Raider, or whichever game you like. Just keep in mind that this is a really big rabbit hole, and there's a whole lot of complicated stuff in 3D that you don't get in 2D. If you go for a 2D game, you can have it running in a few weeks. If you go for 3D, you can have it running in like 2032. You could go a bit faster, but it's a really much more complicated thing. Just for completeness, if you go for 3D, you can take one of these three libraries as example, and you can run Vulkan or OpenGL on top of it. And those go way beyond what we've shown so far. So I want to invite you all. We're with 2, 4, 6, 8, 10, 12, 14 people, counting Oli and Tristan. Pick a simple game. And the idea of the game being simple is not that the back-end implementation of it is simple or that it doesn't have complicated things happening. The thing is that the game itself, to render, is simple. So like Tetris. I have basically pixels, big pixels that move around. I have Solitaire. I have cards, and I move cards. There's a rule set behind it. There's a different rule set for poker, but it's still cards. There's Risk. I have a world map, which is just load an image. There's armies moving around and rules in how they interact, and randomness and interaction. But it's still just putting armies on a background. There's Pong. If you want to go even simpler, just have 2 straight lines and a ball. Move the ball around, hit the wall, hit the side, hit the paddle. That's a simple game. Or go for Breakout, which is a more complicated version of Pong. I'm going to invite you to look online if you don't know Breakout. And the idea of the exercise is to start by taking your game, design the data structures behind it, i.e. for Tetris you would have a playfield, for Solitaire you would have 7 rows of cards that you put cards onto, that kind of stuff. And then start with just having a game loop. So the moment I start it up, I go straight into the game. If I do Pong, the moment I start up, the ball is moving. If I use Tetris, the moment I start up, there's a block at the top and it's moving down. No intro, no animations, no transferring from menu to something else, no options menu, no screen resolution settings. We don't care about that. Just go for the game loop. And don't even go for anything ending the game loop. If you do Pong and the ball is out of the screen, I guess it's just going on forever. Just go for the simple bit. And then try to get to the first image on screen. So for Pong, that would be getting a black screen with a ball. And then second step would probably be just moving the ball and then seeing it disappear. And then take your game from that point and try to go as far as you would like to go with it. So Ollie, I'm going to be handing over to you at this point. I'm not sure what the way of working is around here. So I would suggest we start with the exercise.
So, so who here wants to have a go? Thinks like they're ready to have a go at doing one of these pieces. Is there example code to start with?
There is example code on the Pixel GitHub. We can use that as a starter.
Okay.
It does not have starter code for most of these games. I don't have a empty wireframe for it set up.
Okay.
And the big thing is to first start by thinking about a game and figuring out how the game actually works. What kind of data structures would you use to implement it? How would you keep track of the things going on in the background? If you feel daunted by this, if you feel that you don't have a strong enough grasp of STL, start with Pong, maybe Breakout, because those are relatively easy. If you have a stronger grasp of it, go higher up in the list. I think I ordered them pretty correctly. The simpler ones are at the bottom, the most complicated ones are at the top.
So do we download Pixel?
That is one of the options. The second one would be to download SFML. Either would be fine.
Okay. Let's try and hack together a slide then that's got the instructions on it. So, bear with me, folks.
The alternative, if we're feeling a bit tired or not well willing to go and do things, or we're just a bit tired, we can just go to Tristan's presentation, assuming he's finished it.
Yeah, I'll tell you. You guys are the learners, so you decide. So the choices are you can have a go at implementing something like this, or we can get into parts of the rest of the module that we've been going on, which is, build systems. What do we call it, Tristan? I've forgotten the name.
Core developer skills.
Core developer skills. So
Yes.
hands up for core developer skills. Some of the rest of the next module. And hands up for this. Okay, so
Okay.
it's the majority, and there's people who don't care. So, yeah, that's fine then. It's this.
3 votes, so there's quite a few people who.
So which Visual C++, which is the download, which is the best for SFML?
If you're trying to start, I think SFML is a good choice to start with.
Or MinGW? There's options on the
Let me come take a look with you.
You must have C. Visual C++. First one.
Yes. That would be the one you use for Visual Studio. I didn't ask actually for inventory. How many people use Linux? How many people use Windows? How many people use Macs? So Macs? 2 Macs. Anybody on Linux? 3 and 6 on Windows. 6 or 7. Okay. That's good to know. But you didn't bring it. Oh well.
So what stuff should they get? Pixel? Is it Pixel, right?
Pixel or SFML. Pixel is a library that's meant for beginners, but at the moment it is still an alpha library, so you will find bugs if you try to use it.
Tristan, do you think there's anyone here that would do SFML? I guess that was probably a bit too far, isn't it?
So the alternative is taking Pixel and then going from one of the examples.
Cool, that's perfect. I can't even find the website for Pixel. Where is it?
github.com/dascandy/pixel.
Oh, it's yours. Okay.
Yes.
I was just googling for Pixel.
You just downloaded it.
Yeah, I did.
Yes.
Right.
So do we keep the microphone on for people online, or?
Doesn't matter. I can shut it off. There's nothing to say. Let me just. How can I do this? Can I
But just to remember, the challenge is to take the game and figure out how it works underneath. So given the stuff that you see on the screen, what is actually underneath to keep track of it? How would you implement that? And how do you then display it? And then the fun is to start given that you now know how to implement the game, what kind of structures are beneath it, start with making the simplest thing you can possibly make that shows a part of the game. And then try to add onto that just one small step at a time.